In this demonstration, we freeze bananas in liquid nitrogen to use them as hammers. We put the bananas in a styrofoam bucket and then dump liquid nitrogen on them. Liquid nitrogen is so cold that it boils at only 77 degrees above absolute zero. Here we dump the bananas out. Notice that we're both wearing these clumsy cryogenic gloves to protect our hands from the intense cold. I pick up a nail and try to position it. Charlene picks up the banana and begins to hammer. The amazing thing is not how bad a hammer a banana is, as you can see, but that you can use a banana as a hammer at all. Notice the mist. That's water vapor being condensed by the intense cold of the frozen banana. And when we let the bananas sit by themselves, they become covered by a coating of frost. In the frozen banana demonstration, what we see first is the banana being frozen in the liquid nitrogen. And as that's happening, it might stay whole or it might start to split. Then the banana being used as the hammer to pound the nail. And there again, it sometimes fractures when that happens. And finally, the banana sitting off to the side, it gets a coating of frost while it's still cold, and then when it warms up, it gets all mushy. All of those behaviors are related to the water that's in the banana. The banana is about 75% water. Most fruits and vegetables have lots of water in them. And in fact, it's the water pressure inside the cells that helps them stay nice and firm. For our demonstration, while the water is frozen, that means that the banana is hard. Now, it's not as hard as it might be if we tried freezing it more slowly, so that instead of lots of little ice crystals, we'd have one huge block of ice. And you can see that it would be more strong if it were one huge piece of ice by comparing one large block of ice, large, big enough for us to see, with a bag full of small ice cubes. You can see that although the ice cubes may stick together to some extent as they thawed and refroze, if you drop that bag of ice cubes, all the ice cubes are going to scatter and come apart, whereas you drop the block of ice, it's not going to scatter and come apart into lots of little pieces. If it's strong enough, in fact, it won't break at all. But the banana, as we freeze it, is a bunch of small ice crystals. You can think of them as microscopic ice cubes, which sort of stick together, and they're held together as well by the fibrous structure of the banana. And that's why they can hold together as well as they do and be used to pound a nail. In this demonstration, we'll see how we can freeze flowers and shatter the petals when they are cooled to the intense cold of liquid nitrogen. The little silver device on the table monitors the oxygen level to make sure that the air remains breathable. Charlene has now poured the liquid nitrogen into the Pyrex beaker. That's a special glass that can resist the intense temperature shock. Notice how furiously the liquid nitrogen is boiling around the flower. That flower at room temperature is approximately 200 degrees Celsius warmer than the liquid nitrogen. Now, when Charlene presses on the flower, she can easily shatter the petals because they are so brittle when cooled to the intensely cold temperature of liquid nitrogen. The differences, I should say, between the bananas and the flowers are first that the flowers don't have the same fibrous structure that the banana does that helps to hold all those little tiny ice crystals together, like holding together a bag of ice cubes with some sort of chicken wire or something. That's one difference. The flowers don't have the same fibrous structure that the banana has. Another difference is that the flowers are much thinner. The petals are very thin.